Okay, now I want to talk about something really cool. We've been talking about matching patterns and all that stuff. We've been talking about formatting data. We have regex. We have regular expressions in Bash. They are built into Bash. It has its own regex engine. It might link against the system, whatever. The specifics don't matter. Bash has its own regex engine, and we can use it, which is super cool. So I want to show you what I mean by that. If you've never seen regular expressions before, I'm sorry, it's going to be a little bit confusing. I can't go over all of it in this course, but I can touch on it. I can give you some of the basics, all right? So let's jump into it, and let's talk about, first of all, what do we want and what do we have? Because as you notice, I'm in a directory here that I've already set up. I have a couple scripts waiting for us, and I have an images directory and a want.txt. Let's talk about that. Okay, so in our images directory, it's a little bit of a lie. They're not actually really images. They're just empty files. But take a look. We have two files in there. I'll go ahead and list them for you. We have fun family party and then a random date stamp, and not fun enemy party and a random date stamp. So not fun enemy party is so dumb. So what do we want? Well, luckily we have want.txt. So here's what we want. This is a little challenge for us. We want to take these file names and extract this metadata from it. So we want this date here, but we want the date to show up at the beginning. We want there to be a colon, and then we want the name of the file, which is the part before the left of the hyphen. That's how we want to format this data. So the challenge becomes, how do we do this? Well, we have three different scripts here, and I want to talk about them. So let's go ahead and look at the first script here. Okay, so here is our simple script, and I'm going to walk you through it, so don't worry. The first thing we do here is we define a variable called re. This is our regex. This is how you make a regular expression in Bash. We just made a very simple regex that matches the beginning of the line. It looks for either the text Dave or Joe, and then the end of the line. That's all it does. Now it's in a parenthesis, so we're capturing it, and I'll talk about that in a second. And then our input is Dave. So then we check if input matches the regex, then we print match or we print no match. Now this should match because it's very simple. Dave should match against this regex of simply Dave and Joe. So once we're in this branch of the if statement, there's something kind of magical that happens here. We have a magic variable called bash rematch, which is for the regular expression match. It is an array. There are multiple elements in this array, so let's go ahead and print out what is in this array. So there we go. We are printing out bash rematch. Let's go ahead and close those quotes right there, and we're going to print out every element separated by new lines. So when we run this, we can see that there are two elements, Dave and Dave. They might be a little bit confusing, but if you've used regex in the past, it will make sense to you. What's going on here is the full string is always the first match, the first part of the array. The first part of the array is always the full string. That is everything that was there. And now this one is the first capture group, and then so on and so forth if there were more capture groups. So we have Dave and Joe here. Now in this example, it's just going to match the full string always, so that makes sense. Let's go ahead and change this to just beginning with D or beginning with Joe and having anything here at all. So that means it has to start with a D or has to start with a J, but we have parentheses around it. So if we rerun this, it will match the full string was Dave, and the part that matched, the part that we captured, was D. So that's what's going on here. This is the basics of doing regex here in Bash, and it's incredibly powerful. So let's get back to our original challenge here. We have these images, and we want them to look like that. We want to print this to the screen. Well, let's go ahead and look at our fine example. If we look at our fine example, you can see we do for f in images star. So we're going to loop over every file that is in the images directory. We're going to get the base name of the file. Then we're going to echo the base name, pipe it to cut. We're going to cut it based on hyphens, and we're going to get the first field. That might be a little bit confusing. Let me go ahead and pull up the source code for that, and let's go ahead and ls the images. All right, let's do them separated by new lines. So we're going to get the base name of this file. So the base name is this whole string. Then to get the name, we're going to take the base name and put it into cut, look for the hyphen and grab the first field. So here's the hyphen. We're going to grab the first field here. Notice there is extraneous white space to the left of it. Then we're going to grab the second field and so on. So everything after the hyphen, because look, there are also still hyphens here. So we're going to grab all of this. We're going to cut it based on a period and get the first field. So we're going to get just this section of it. And then we're going to pipe it to xargs echo. This is a nice little trick to get rid of extraneous white space. Remember, this is a fine solution. If I saw a script like this and it was quick and dirty, I'd be like, yeah, I know what you're doing. I get what's going on here. That makes perfect sense to me. So if I run the fine script, hey, look at that. It gives us what we want. It works. It works for all intents and purposes, and it's fine. There is a better way to do this if you use regex. Let me stop right there. I don't have a problem with this. I think this just could be rewritten to have a much less fork and exec and to use a lot of bash built-ins. Like, again, if I saw this, I wouldn't be like, oh, this is terrible. I'd be like, no, this is a bash script. I understand what's going on here. But let's look at how we could redo this with regular expressions. So, like I said, if you have never seen regular expressions before, you're going to look at this and be like, Dave, are you really telling me this is easier? Unfortunately, yeah, because like, I don't know, I kind of just like regex, so I look at this and I can see exactly what's going on here. So we're matching anything up until a slash, and then we want anything with a space hyphen space, and then we're looking for is a number 4 times, a number 2 times, and a number 2 times, because remember, year, month, day, and then dot anything, because there's going to be an extension. So we loop over the files, we check if the regex match. If it didn't match, we just try again. We just do the next part of the loop. We have pretty decent error checking here. Then we can extract the name by looking at the first part of the array. Then we can extract the date, and then we just print this. So even though this might be confusing and it's tough to write this once you have this, look how simple this becomes. So again, this is a static choice. This is a personal preference if people like regex or not. There are people who are like, no, I don't ever think it's the right solution. And you know what? I kind of low-key agree with them, but it's an incredibly powerful thing, and I would be remiss not to show Bash's regex engine because it's really, really powerful. So look at this. We get the same output here. We're using regex, and the cool thing is we're not forking out to external tools. So if we were to run, what is it, 01, it does a lot of fork and exec for all those tools. We could time this, and we can see that it takes 0.039 seconds. Again, very fast. When you're benchmarking something, you shouldn't be, you should be in the realm of seconds, not milliseconds, because then you're getting down to the level of like the system actually having to do things. Long story short, if we run this, we can see that it executes roughly, 3 times faster. So if you were doing this across a lot of files, you can see that that would make a big difference. Yeah, 0.039 for the fork and exec version, 0.013 for the regex version. We're not forking any external tools. We're using all bash built-ins. So again, if you were doing like a lot of data, a lot of batch processing, then this is just probably going to be faster. It's still regex. It might be a little bit brittle. Again, if you're using regex to try and parse something out, you're probably not in the cleanest API that's ever existed, but you know, that sometimes you're there. Sometimes you just need to bust out the regular expressions and hey, bash has them built in. That's the point of this lesson.